Looking at the homework for vectors, we are converting the vectors from component form to polar form. Number one, we have 4 vectors. The first vector is vector A, and it is right 1 and up 1. Now, hopefully you recognize this as if you draw a reference triangle. This is a 45, 45, 90, which means if the leg is 1, the hypotenuse is square root of 2, and theta is 45 degrees. So that makes vector A have a magnitude of square root of 2, and the angle in standard position is 45 degrees. Vectors B, C, and D are all going to have the same magnitude because the legs in each case are 1 and negative 1, which just is going to change our direction but doesn't change the length. So we know that these vectors all have a magnitude of square root of 2. It's just a matter of what is the angle, what is the direction. Well, if vector B is over here in quadrant 2, and this reference angle is 45, it's going to make this angle from here to here 135. If we take and we put vector C, it's going to be in quadrant 3, like so, and its reference angle is 45 degrees, that's going to make the angle in standard position 180 plus 45, which is 225 degrees. That was harder for me to figure out than it should have. Embarrassing. Vector D is going to be in quadrant 4. Its reference angle is also 45. So the angle in standard position is going to be 360 minus 45, which is 315 degrees. So here we have these 4 vectors. They all have the same reference triangle, they're just in different quadrants. Therefore, the radius or magnitudes are the same, and the angles are going to change depending on the quadrant. Number 2, I've intentionally grouped these 4 together as well because they are going to have the same reference angle. Let's do E first, which is in quadrant 1. Vector E. If we go to the right one and up the square root of 3 for vector E, this is going to be a 30, 60, 90. Draw a reference triangle. X is 1, Y is square root of 3. That's going to make the reference angle 60 degrees, and that's going to make the magnitude 2, because the hypotenuse is always twice as big as the short leg. Therefore, vector E is going to have a magnitude of 2, and it's going to have an angle of 60 degrees. Vector G, well, that's going to be in quadrant 2 because it's left and up. Same magnitude. And if this is 60 degrees, this is going to be 180 minus 60. That's going to make this angle here 120 degrees. Vector J is in quadrant 2, has the same magnitude because it has the same components, just in a different direction. That's going to make the angle 180 plus 60, which is 240 degrees. And then vector Z, which is going to be in quadrant 4, if its reference angle is also 60 degrees, it's going to make the angle in standard position 360 minus 60, which is 300 degrees. Once again, they all have the same magnitude because they're the same. They have the same lengths for legs, just the orientations are different. Let's check out number 3. Number 3, vector F is in quadrant 1. We're going right square root of 3, and we're going up 1. This is a special right triangle with a reference angle being 30 and the hypotenuse being 2. Therefore, the magnitude of vector F is 2, and the angle in standard position is 30 degrees. H is going to have the same magnitude of 2. Its reference angle is 30, which means the angle in standard position is going to be 150, 180 minus 30. Vector I has a hypotenuse, has a magnitude of 2. Its reference angle is 30 degrees. Angle in standard position is going to be 180 plus 30, which is 210 degrees. And then finally, vector K, its magnitude is also 2. It's the same triangle, just in quadrant 4. Reference angle is 30, so that means this angle in standard position is 360 minus 30, which is 330 degrees. Notice, once again, each of these angles have the same reference angle of 30. Each of these angles have the same reference angle, 45. Each of these angles have the same reference angle, 60. Number 4, these are not special right triangles at all. This is actually much easier. Vector M well, that's not M. My apologies. Vector M is going to the right 1, doesn't go up or down. So what's the length of that vector? Well, it's 1. What's the angle? 0 degrees. Vector N, which is going to be up here, it's 0, 1. Its length, 1. Its angle, that's 90 degrees in the standard position. Vector P, its left 1, so its length is 1, and its angle is 180 degrees. That would be over here. And then vector Q is on the negative y-axis. Its length is 1, and its angle is 270 degrees.